Today we are going to look at Surds. Mathematics is a universal language for the sciences, the social sciences, and whatever. So the topic Surd is the same anywhere all over the world. The rules guiding the solutions are also the same. So it does not matter where you are, you apply the rules, the solutions will also be the same. By definition, surds are irrational numbers. They are irrational numbers. In other words, they don't have exact square root. For example, you can look at the square root of 2, the square root of 3, the square root of 5, square root of 10, per etc. These are surds. Note that recurring decimals such as 3 recurring, such as 0.3 recurring is not a surd, as it can be written as a fraction. We are also going to look at the rules, the operating rules of surds. Rule number 1. If A times B under square root is the same thing as root A times root B. Rule number 2. Or we can also give an example of this. Maybe 9 times 4 is the same thing as root 9 times root 4. The result is the same. Here you have 36 under square root. Here you have 3, and the square root of 36 is 6. And then you have root 9 is equal to 3. And then you have root 4 is equal to 2. And 3 times 2 is equal to 6. So you discover that they are equal. That is the first rule of surd. So multiplication of surd can be done separately. Let's take the second rule, rule 2. If you have the square root of A all over B is the same thing as the square root of A all over the square root of B. Rule number 3. A root B is the same thing as A squared times B all over square root. Another rule is the rule of rationalization. Rationalization. If you are given A all over root B, you can rationalize this by multiplying the denominator and the numerator by the square root of B. That is A all over root B times root B all over root B. In this case, the numerator becomes A root B and the denominator becomes B. You have rationalized the denominator, you have made it a rational number. Rule number 5. we talk about the conjugates of a surd. If you have A plus root B or A minus root B, these two terms or these two surds are conjugate of each other. A plus root B is the conjugate of A minus root B. Similarly, A minus root B is the conjugate of A plus root B. We use these to rationalize surds of the following type. For example, you are given A plus root B all over A minus root B, and you have to rationalize this surd. You have to multiply. The conjugate of A minus root B is A plus root B. So you multiply the numerator by this and also multiply the denominator by the same value. By the time you do this, you will now have A plus root B multiplying A plus root B, everything all over. A times A is A squared, and then minus root B times root B will be equal to B. You have made it a rational value. This is what we use the conjugate of surd to do. We use it to rationalize a surd of this type. Similarly, if you have surd of this type, similarly, root A plus root B all over root C plus root D will be equal to root A plus root B all over root C plus root D. Multiply this by the conjugate of this one. The conjugate of this one is now root C minus root D, and of course the same thing here, root C minus root D. If you look at this, you simplify it to become root A plus root B multiplying root C minus root D. And everything here will be divided by root C times root C is C, and then minus, because plus times minus is minus, root D times root D will become D. Again, you discover that the denominator is now a rational value. We will now continue our discussion by looking at some examples. Let's look at some examples. The first example will be if 2 root 3 minus root 2 all over root 3 plus 2 root 2 is equal to m plus n root 6. And then we are required to find the values of m and of course n respectively. Our solution is as follows. You have 2 root 3 minus root 2 all over root 3 plus 2 root 2. You have to multiply the numerator and the denominator by the conjugate of the denominator, which means the positive become negative. You multiply it by root 3 minus 2 root 2 all over the same root 3 minus 2 root 2. In other words, you multiply this by this, that will give you 2 times 3 minus, take this to multiply this again, that is 4 root 6, because 3 times 2 is 6 under root. Then take this now to multiply this, minus 2 times 3 is 6 under root again. And then take this, minus times minus is plus. Then root 2 times root 2 is 2, times the 2 there is now 4. Everything here, all over root 3 times root 3, which is 3, minus 2 times 2 is 4, root 2 times root 2 is 2, so 2 times 4 will give you 8. Now simplifying further, that is 6 minus 5 root 6, and then plus 4. Everything here, all over minus 5. Now, adding the like terms, 6 plus 4 is 10, minus 5, root 6, and all over minus 5. You discover that you can divide through by 5. 5 can divide this, 5 can also divide this. Therefore, minus 5 into plus 10 is minus 2. Minus 5 into minus 5 root 6 will give you plus root 6. So we can have this result like this, or you write your answer as minus, open bracket, 2 minus root 6. These two solutions are acceptable. It therefore means that we have minus 2 plus root 6 equivalent to m plus n root 6. So your m is equal to minus 2 and your n is equal to plus 1. And this is the result you are asked to find. Another example 2. You are given that p is equal to 1 plus root 2. And you are also given that q is equal to 1 minus root 2. And you have to evaluate p squared minus q squared all over 2pq. Evaluate this. Our solution. Now you have your p squared will become 1 plus root 2 all squared. And when you expand this, you have 1 plus 2 root 2 and plus 2. You take your q, also squared, you have 1 minus root 2 all squared. That becomes 1 minus 2 root 2, and then of course plus 2. Now let's take our p squared minus q squared, which becomes 3 plus 2 root 2 minus 3 minus 2 root 2. This simplifies to become 3 plus 2 root 2 minus 3 and then plus 2 root 2. In this regard, 3 and minus 3 will go, so you have 2 root 2 plus 2 root 2, which is 4 root 2. You now take your 2p times q. This becomes 2 into 1 plus root 2 and then into 1 minus root 2. The result of this is 2. 1 there, 1 times 1 is 1. This is a conjugate of each other. So root 2 times root 2 is minus 2. This is equal to 2 into minus 1. And the value is minus 2. Therefore, the final result becomes dividing 4 root 2 by minus 2. And this will give you minus 2 root 2 as the solution. Example 3. Simplify. Root 98 minus root 50 all over root 36. Let us simplify this. Our solution, You will observe that all we need to do in this case is to factor the numbers into a perfect square and another number. For example, your root 98 is the same thing as 2 can divide it to give you 4, and then that is 9 times 2. And 49 is a perfect number, a perfect square, because we can find the exact square root. Everything here under square root. 50 is the same thing as 25 times 2, and then this is also under square root. And then 36, we know that one is already a perfect square, so that value there will be 6. Okay, let us still leave it as root 36. Now, simplifying further, 49, remember the rules of solve. This becomes root 49 times root 2 minus root 25 times root 2. Applying the rules of solve. Everything here all over root 36. So we can break it down. Root 49 is 7 times root 2. Root 25 is 5 times root 2. And everything here all over 6. 7 root 2 and 5 root 2, they are common. They are like terms because they have the same root 2. So this becomes, it's like saying 7s minus 5s. So when you subtract this from this, you have 2 root 2 all over 6. 2 can now divide both the numerator and the denominator. So that becomes root 2 all over 3. And that is the solution to the problem. Example 4. Simplify the root of 48 minus 9 all over the root of 3 plus the root of 75. They are asked to simplify this. Alright, your solution. If you take a look at this, 4 can go into this. 4 here is 1 and 2. So this becomes 16 times 3 on that square. Minus 9 all over root 3. Rationalize it to become root 3 and then divided by root 3. Plus, this is 25 times 3 also on that square. Let's see what happens. We already know that root 16 is 4 times root 3. This is 9 root 3 all over 3. And root 25 is 5 and then root 3. Let's simplify further. This will give you your 4 root 3. The 3 here, we cancel this to give you 3. So you have minus 3 root 3. And then plus 5 root 3. Recall the rules of Bodman's. The rules of Bodman says addition before subtraction. If you add this to this, you will have the wrong answer. So this becomes 4 root 3 plus 5 root 3 minus 3 root 3. You can also subtract this from this and you have root 3 and add it to the same process. Now this will become 9 root 3 minus 3 root 3. And eventually this will give you 6 root 3. And that is the solution to the simplification of that problem. Example 5. Find the value of tan 60 degrees minus tan 30 degrees all over tan 60 degrees plus tan 30 degrees. Solution. you record from your special angles the value of these angles. So we write the surd equivalent of these angles. We know that tan 60 is root 3 and tan 30 is 1 all over root 3. Everything here all over root 3 plus 1 all over root 3. This is what you now have. And in order for you to solve this problem, you now take the conjugate. Multiply this by root 3 minus 1 over root 3. Everything here all over the same root 3 minus 1 all over root 3. The result of this will be root 3 times root 3, which will give you 3. And root 3 times minus root 3 will give you minus 1, because root 3 will cancel root 3. Then you take this and expand. 1 all over root 3 times this will also give you another minus 1. Then minus times minus is going to be plus. And then this times this will give you 1 all over 3. Everything here will be root 3 times root 3 is 3. And then 1 over root 3 minus that times minus that will give you also 1 over 3. You have rationalized, and we now have 3 minus 1 will give you 1, and then plus 1 over 3. And then you have here 3 minus 1 over 3 is 2 over 3. So you actually have here 1 over 3 all over 2 over 3. Of course, this becomes 3 times 1 is 3 plus 1 is 4 all over 3 times 3 times 2 is 6, 6 plus 2 is 8, inverting 3 all over 8. The result is this will cancel this, and this will cancel this 1, this will cancel this 2, so we have 1 over 2 to be the solution to the problem. Let's take another example, example number 6. We are given that root 2 is equal to 1.414, and we are required to find, without using tables, okay, the value of 1 all over root 2. Okay? These are common questions that will come your way. Our solution, we have 1 all over root 2 will be equal to 1 all over root 2 times root 2 all over root 2. What have I done in this case? I am rationalizing to make it simpler. If you do this, you now have root 2 all over 2. You can now substitute the value given to you for root 2, which is 1.14 all over 2. You carry out the division, 0, 2 into 1 is 0, cannot, point, into 14 is 7, into 1 again is 0, and into 14 is 7. So this gives you the answer to the problem. You now observe very carefully here that the rationalization helps us to solve the problem more easily than when you now substitute 1.414 at the beginning. That division will be a little bit cumbersome. So the good thing about this, about rationalization, is simplifies the problem. Okay. So success is an inevitable reward for hard work. Exercise. Number 1. Simplify 0.7 under square root plus the square root of 70, bracket open and closes, all squared. And then you have the options A, 84.7, B, 70.7, C, 217.7, D, 168.7. Number 2, simplify 1 all over root 3 plus 2 in the form A plus B root 3. Options are A, minus 2 minus root 3, B, minus 2 plus root 3, C, 2 minus root 3, D, 2 plus root 3. Number 3, find y if root 12 minus root 147 plus y root 3 equal to 0. Options are A, 5, B, 1, C, 7, D, 3. Number 4, simplify, bracket open 1 all over root 5 plus root 3 minus 1 all over root 5 minus root 3, bracket closes, times 1 all over root 3. Options are A, root 15 all over 5, B, 2 root 3 all over 3, C, minus 2, D, minus 1. Question number 5, simplify 4 minus 1 all over 2 root 3. Options are A, 2 root 3, B, 2 minus root 3, C, minus 2 plus root 3, and D, 2 minus root 3. The answers are number 1, option is A, correct. Number 2, option C, correct. Number 3, option A, correct. Number 4, option D, correct. And number 5, option B, correct.